Hello, I am Seungjun Na from Seoul National University. I'm going to present about the NTIRE 2021 challenge on image deblurring. This challenge was jointly organized with my colleagues Sang-Hyun Son, Soo-Young Lee, Radu Tiboktae, and Kyung-Moo Lee. Before going into the challenge details, let's review the previous versions of the challenge. 2 years ago, we released REST dataset in NTIRE 2019 Video Deblurring and Super Resolution Challenges. REST dataset initially had 4 types of video degradation artifacts: motion blur with MPEG compression, low resolution, and low resolution with motion blur. Since then, REST dataset has served as a benchmark platform for image and video restoration tasks and used in the NTIRE and AIM challenges. In NTIRE 2019, we hosted 4 challenge tracks that correspond to the REST video degradation types. In the next year, the challenge was hosted to encourage developing image deblurring methods as well. Also, the mobile deployment of solutions was investigated. The winning methods in the past challenges proposed state-of-the-art model architectures. In 2019, the well-known EDVR was proposed. In 2020, wide atraus block and efficient dense residual UNet were presented for image deblurring and the mobile deployment. They brought much attention from the community, and the schemes are now popular. Now, let's move on to the 2021 challenge. In the past challenges, we aimed for image and video deblurring with high fidelity on REST dataset. We also consider the practical application by deploying the solutions to mobile devices. In this NTIRE 2021, we focused on more realistic settings as real-world images typically suffer from multiple artifacts. Thus, we set the challenge goal to develop image deblurring solutions considering the joint artifacts, low resolution, and JPEG compression. To achieve the challenge goal, the competition is organized by setting 2 tracks in parallel. The first track involves a low-resolution artifact as well as the motion blur. And the second track requires the participants to handle images suffering from JPEG compression artifacts. Compared with the uncompressed blurry images, the blurry JPEG is more blocky. During the challenges, the REST dataset is provided with the 3 subsets. The training and validation datasets were given with the corresponding ground truth images. In contrast, the test data was only provided with the input images. The challenge participants were asked to use the training set to train their models and the validation set for development feedback. The submitted solutions were evaluated with the conventional PSNR and SSIM metrics. The reproducibility was checked by the organizers in a unified environment. For further analysis, ELPIP score was also provided for reference and analysis purposes. The challenge lasted for 3 months. The development phase intermediate solutions were handled via Codalab online platform. The final results were submitted by email along with the fact sheets and the source code. Due to the large number of submissions this year, it took a month to determine the final scores and ranks. Several submissions violating the rule were rejected. With the roughly 300 registered participants on Codalab, 18 and 17 solutions competed in the final phase. Interestingly, we witnessed consistently increasing number of participants for the image and video deblurring challenges. Thank you for your cooperation. Now, let's take a look at the challenge results. Here are the results scores for Track 1 and Track 2. In Track 1, VIDAR team achieved PSNR of 29.04, followed by NetAI and Njust AMOC teams. VIDAR's solution was faster among the high-ranking teams. In Track 2, the fat, the thin, and the strong team showed the best PSNR, while VIDAR team showed higher SSIM and lower LPIS. The first place in Track 1 was won by VIDAR team. They proposed enhanced deep pyramid network adapting EDVR for image deblurring with joint artifacts. We note that they also achieved good scores in Track 2. Here are the visual comparisons of the different solutions. From the low-resolution input blurry image, top-ranked solutions achieved the good results. In the second row, the text can be better recognized on the best result by VIDAR. In Track 2, the fat, the thin, and the strong team won the first place. They proposed HINet with their half-instance normalization blocks. They normalized part of the feature channels instead of the whole channels in their model building blocks. Here are the visual comparisons of the second track solutions. The top-ranked solutions recovered the image details from blocky and blurry images. Especially, the water gun from the fat, the thin, and the strong team exhibited better sharpness compared to the other teams. To summarize, we organized NTIRE 2021 Image Deblurring Challenge to cope with more realistic artifacts in common scenarios. State-of-the-art performance was achieved by top-ranked solutions handling the low-resolution and JPEG compression artifacts. Still, there remain rooms for improvements. For example, the perceptual quality could be further improved, and the running time could be faster considering the practical application. More details can be found in the challenge report. Let me conclude this presentation by giving thanks to our sponsors. The NTIRE 2021 workshop and the challenges were supported by them. Thank you. This is the end of my presentation. Thank you for your attention.